Hi everyone, and I'm back again, wanting to get a good chunk done this weekend in terms of catching up with language features. So where I left it yesterday was I just added arithmetic operations, and so what I'm going to do as a follow on today is add the booleans to start off with anyway. So a lot of these are going to be, I would say, relatively straightforward. They're going to be basically just similar to the arithmetic operators, just pulling in the more or less the code that I've already done for this previously, cleaning it up a little and then adding tests and the like for it. Now, whether I want comparison operators as well, I think I will throw those into the mix as well. Now, I won't do equality because I'll be, at least as part of the first commit anyway, because I'll be diving deeper into that. Because, oops, let's see, how do I do a search for and? So the reason I won't be doing equality is because in the language it'll be structural equality, so I'll be implementing, say, a recursive algorithm to do that. So in the meantime, and I better copy over less than and greater than as well, and those go above modulo. And so I'm going to be focusing on the non-direct equality operators to start off with. So let's see. So I'm going to have to bump the precedence of the operators that I've done so far, because I'm going to have these and ors are going to have the, I believe, loosest binding. Yeah. So that will mean that if I do something like this, so if 1 equals 2 or x is equal to 1 and y is equal to 2, that will essentially parse like this. So I want the binding of the ands and ors to be particularly loose. So let's go ahead and do those then. So that's going to be and, that's going to be or, and I'll have to add the AST productions for those as well. So I'm going to have to bump those, that. And I think that's all of the ones that I needed there. And so we're also in precedence level 3. I'm going to have these guys, and that's going to be, whoops, greater than equal to, and that's going to be less than equal to. So that's the tokens not being found. So let's go ahead and open up the Lexer. So we have and or being added here. Though whether it should be ampersand, and pipe, I'm not sure, but maybe that would make sense actually, because the rest of these names are referring to the symbols rather than the operations that they perform. Kinda. There's a mix. Yeah, we'll do it like that. And so we'll do greater than, less than, goes above mod, and okay. And so we'll jump down here. So match double symbol token. That's going to be amp. So I'm gonna have to sort those, but afterwards anyway. So let's see. R is going to be pipe greater than equals. We're gonna go in there, and then I'm going to grab the single character tokens. And that's all of them for the moment, I think. So R, yeah, I haven't. So that should be, oops. Let's try this. Cool. And already we're seeing slightly longer compilation times as well, as the Lalorpop file is getting bigger. So let's see the valmod 408. We want to add more binary operators. So this will change to a catch-all, and what are the operations that we've just added? Well, we have and or for the Boolean operators. Greater than and greater than or equal to, and less than or equal to. So I'll need to implement those on a couple of types. Will I? No. Well, it'll be on integers anyway. So what other types do we have? We have bools, int strings, lists and objects. So I think those will be fine for just So I'm going to group these under Boolean operators in terms of operators that give Boolean results. So let's see here. Let's try that. 394. What am I missing? So I'd say I've introduced an extra parenthesis or an extra brace somewhere. Let me see, what does this pair up with? Yeah, so that pairs up with that. Oh, is this it? I think, yeah. Why don't I have to dereference the borrows elsewhere? Not really sure. To strings. There's a lot of duplication in a number of places in terms of the converting both operations and different symbols into their token form and back again, that I should really handle in a more uniform way at some stage, but that should be an easy enough simplification to implement later. Yeah, here being a good example of that as well. So we have the first errors to come up every time I add new tokens is the unexpected EOF error, because it says, oh, we expected one of these tokens, and every time I add a new token, it has to be added to the list of tokens we would have expected instead of an EOF. Wonder if there, could I simplify that and just and it should just say expected a semicolon. Nah, basically the same. Yeah, that simplifies things. Like, all I really want to do is just check that, basically check the error that occurs when an EOF is encountered. And so it doesn't have to be anything too complicated. That should suit my purposes. And so we want to add some new tests for Boolean operators. We want to update the features file, and we want to update the features document. Operations on integers. And we want Boolean operators and comparison. And in the next one we'll do equality as well. So arithmetic we'll do Okay, so I don't have the operations in the features file at the moment. Oh wait, I do have some up here. It does contain a capitalized acronym. Yeah, I guess. I was actually deliberating whether to do that previously, but I guess Clippy kind of makes a strong argument there. Or rather, the fact that it makes an argument in any direction is a strong argument for me, because I was basically on the fence anyway. And it's really not much concern to me, only that as long as it's consistent, doesn't bother me too much. Which actually, whether I use the capitalized version or not. Cool, so let's see where we are now. I'll put in some more docs just for a bit of completeness, because that does look kind of lonely on its own. Nice catch. Fairly sure I sorted those already, but no harm in doing it again, just to be sure. Those in place, I think that's basically all the operators bar the equality ones. So let's see. So that binds relatively tightly. Oh yeah, so it goes with the rest of the comparison operators. I put those on in different orders in the different declarations. Okay, so equality. Let's see how we're going to implement that. The value is one of the primitive types. Well, first of all, if both are null, of the null type. Then we'll go through. Oh, I probably can't do that because they're all different types. I'll have to create different branches for each. Oops, that's not right. Yeah, so then we have our two lists, and the way that will work is go. So I'll just do a get, because we've checked the length previously, we should have exclusive access to the list, so it shouldn't get modified out from under us. So an invalid access at this point would be a panic, but that shouldn't happen. So let's see. Do invalid op types at this point. But I can return a unit error. I would say because there's only one type of error, it could be at this point. Little hacky, but yeah, I'll do this for now and maybe clean it up once, if and when it's working. Expected a bool. Ah, yes. So true, and then it'll return none if there was a type error. To capture those as well, or unlock them rather. And I can use the same logic as I do for applying binary operation. To clone value and HS value and RHS lock, unwrap V and take the address, and we'll add a similar comment above here, so we'll say C comment above call to apply binary operation in eval expr for details on why we clone the value from inside LHS, inside the LHS mutex. Let's try that. HS value is not in that scope, that's correct. And that's not found in value. Oh yeah, because this should be Y and that should be X. There, so we'll propagate any type errors. Now that could have somewhat surprising effects if the type mismatch is kind of buried in a structural recursive equality check, but I'm not really too worried about that. So 514, what's the issue here? Consider borrowing. Yeah, I could do that. And in fact, I might around slightly here. Maybe I'll leave it the way it was. More lines, but I think it's slightly clearer. I mean, there's already a couple of things going on in this line with grabbing the address of X and cloning the inner value and then getting the address of Y, or the address of the thing that comes out of it. So I think not adding more clutter per line. I think Rust is very nice in that it gives you a lot of tools for static analysis, but it does mean that lines can become quite noisy very easily with a lot of symbols and a lot of clutter, and each of them are necessary, but it does make it a little difficult to read, in my opinion, and that's why I'm very liberal with the likes of line breaks when I'm writing Rust code, because there really can be a lot going on in one line. So anything to make things a little clearer is very helpful, I think. So I don't have a handler for object equality at the moment, but I will add that in momentarily. So if the operator is sum, then I will do an equality check on the left hand side and right hand side, and if the value works. Oh, hey, yeah. So thanks for the question. So in terms of stage, am I on Lexer, Parser, or backend part? So kind of all at the same time. So the language itself is fairly fleshed out at this point. So what I'm doing now really is kind of rebuilding a language that I've implemented previously, but now tidying up the code and refactoring little bits here and there, and also adding comprehensive tests is kind of one of the big things that was missing previously. So I said, in an effort to make sure that everything was fairly comprehensively tested, I would build it again from the ground up, but with those tests at each layer. And so I have a working Lexer, Parser, and evaluator implemented at this point, but those are all only feature complete in terms of the features that are there so far. So each time I add a new feature, each layer of both the parser, the Lexer, and the evaluator will all get incrementally updated as well. And so in terms of the language ideation as well, as I've mentioned in some of the other streams, this is really just going to be the core, which I'll be using as a base for playing around with different language ideas. But later on, I will be adding maybe some more. I will be branching off of this project and adding maybe more novel ideas to that. What I'm doing at the moment is kind of baseline in terms of the features that are there. So it'll look, for the most part, a lot like JavaScript, I suppose, in terms of the basic types and things like that, and it's somewhat prototypical. But it'll be when I'm adding those more novel bits that I'm hoping that the unique aspects of the languages I have ideas for will shine. So I hope that answers your question. So here we have an invalid op types error if the equality didn't pass, and then we'll do an OK bool here if it did have a proper equality check working, and that shouldn't be sum, that should be eq. And I'm just thinking, oops, why isn't that? Oh yeah, there we go. Carbon language, Lexer and Parser. Okay, interesting. Yeah, like there are lots of different approaches to, I guess, building a language in general, and I know there's the likes of LLVM for handling backends, and you also, I guess, have peg grammars and the likes for handling different types of, shall we say, not sure even how to distinguish because I don't even know much about peg grammars really, but yeah, there are a lot of, I guess, with so many developments in the programming language space, implementing it the kind of old-fashioned way, the way I'm doing here, so to speak, is probably not the best approach, but it's kind of, I'm at this point with programming as well where I kind of go for, I guess, lowest barrier to entry, if that makes sense. I have a lot of projects that I kind of dive into, and the less stuff I have to research before just diving right in. Trying to make a dense AST and tokens to increase cache locality. I mean, that sounds good. It sounds like there's a lot of benefits to that approach. At the end of the day, I don't know, have I gotten into a more of a business mindset of all these kind of things? But I don't know, sometimes, like at the end of the day, really all I'm trying to do is, and especially with this language, is just try some, I guess, put different, I guess, language features to test in a way that's familiar to me. And at least for me anyway, I can get really bogged down with the best way of implementing it and things like that. And that would be my fear if I looked into something like the likes of, I don't know, LLVM or Carbon or different peg grammars and things like that. At the end of the day, what I'm doing is, for the most part, fairly simple, I would say, and gets me the satisfaction of getting what I want to working. But yeah, like, I mean, increasing cache locality sounds like it makes a lot of sense to me. I don't really know entirely what that would entail or what benefit, I guess, performance is usually the one. I mean, this language that I'm doing here really isn't going to be that performant, I'm sure. Well, it'll probably get a good amount of speed owing from the fact that it's written in Rust, but I really won't be optimizing it too much into iter 522. I mean, the first step for me anyway is to get something, or rather anything, working, and at that point then I might start at making things a little more performant and the likes. But is that, oh yeah, and I need to, if op is equal to sorry, kind of trailed off there. And if we go into this branch, then it should only be the not equals branch. Look into ML intermediate representation if you want to lower the code to assembly. Yeah, like again, all those things are useful, but the more, yeah, like at this point, I'm really just implementing the evaluation just directly on the ASTs. And yeah, I probably am reinventing the wheel and the likes of it, but you know, that's not too much of a concern of mine. But thanks very much for the suggestion. I'm a while out of the game in terms of programming language implementation as well. So there's probably a lot of stuff that I'm doing that's particularly old school. But yeah, like I say, my first priority is to get something working, and then I might start looking at what are the ways that it can be improved, and for example, yeah, targeting different environments and things like that. But for the most part at the moment, just getting the programming language working the way I want and playing around with the ideas that I have bouncing around my head is kind of, because what can often happen as well, or at least what I've encountered, is that you can encounter these tools and you can encounter these tools and frameworks that sound like they're 95% what you need, and then you encounter those tricky edge cases where you're developing the majority and you get the majority working just right the way you want it, but then those edge cases can be the things that trip you off or trip you up even early on. I found that with Lallerpop as well. Even something recently that, again, I'm sure that people smarter than me, or if I had more time on my hands, that I could get over. I mean, one example of this was the fact that the Lallerpop parser generator generates LR1 parsers, which makes sense. I feel that's kind of standard in a lot of areas. What am I adding here? Oh yeah, equality. And so that was fine for the most part, but a weird edge case that I came across recently was that when I was adding support I had added support for objects, again using the likes of JavaScript notation, but then when I added support for blocks, the Lallerpop parser generator was tripping up on the fact that when it encountered the closing brace for or just a closing brace, it couldn't determine at that point whether that was going to be a block or an object, even though examining the next token would clarify that. And again, if I had used a peg parser generator or the likes, that wouldn't have been an issue. But for me anyway, I often find that I only find these things out once I'm a little bit along. And so sometimes just going with what you know, at least for me at this point where I feel like I don't quite have as much time to spend on things as I would like, that can be what's it called? The devil you know sometimes can be useful for just getting things done. And I'm kind of at that point as well. also did experiments on language by creating a val on AST. Able to think a proper language syntax. Okay, interesting. You need recursive parse to end look ahead parser. Yeah, probably. I mean, I ended up getting past the issue by just being a bit cheeky and saying, okay, well, if you open a block, then you need to have a statement in it. You can't have you can have an empty object, but you can't have an empty block. So I was a little cheeky with my approach in that. And it's a fairly serviceable workaround. But yeah, I mean, like you say, I would have had to probably know that information ahead of time and actually choose a different type of parser generator to support that. And that can be some of the trickiness of using tools. I mean, don't get me wrong, I'm so glad that I'm using LalerPop because it saved me a ton of boilerplate and redundancy and things like that. But there's, I guess, it just a reminder of the fact that there are pros and cons to every approach, and you rarely get everything for free. So let me see. So we've comparison. In fact, I'll separate this out into an equality block. Whoops. Equality. So I better add some tests for those to make sure that they'll actually do what the documentation says they'll do. And in fact, I also haven't yet implemented the object structural equality, so I need to remember to do that before I move on as well. Create language syntax inside the language using compile time concepts and intermediate representation. Move as much keywords and syntax into standard header library. Yeah, I think that's a nice idea, like hiding the almost the language complexity into some of the standard library as well. I've had well, maybe not similar, but what it reminds me of in terms of the language I'm designing as well. So the language that I want to develop based off of what I'm currently writing is the user can create their own keywords. That's pretty cool. Kind of macro style, or how would that work? So what that reminds me of in terms of the language that I'm developing is that there are a couple of, so the language that I'm developing is mostly designed to be a replacement for Bash, at least in terms of the programming language side of Bash, or scripting language. And so let's see what's going on. Oh, was that just a holdover from that being there? I think that should pass. Yeah. So some of the bits about Bash that I feel there can be a bit of bike shedding around is the fact that, instead of using cat or, I don't know, getting output from different sources, you can use pipes and redirects in different configurations and things like that, and that'll be more performant because it'll be Bash actually performing the operation instead of calling an external program to do it. But then I feel like that adds so much complexity, and kind of, because Bash isn't so well known, it creates this kind of internal knowledge, so to speak, even though they're not really hidden secrets. I guess they're in the documentation, but so few people use Bash to that extent that it kind of is somewhat hidden knowledge. And I feel if you created a Bash standard library that kind of abstracted those kind of bits and just exposed, I guess, well, when I say standard library for Bash, it actually is more in the lines of other programs that you can then, I know it's too much in my head for me to explain right now. I wouldn't be able to explain it that well, but that just reminded me of some of the thoughts I had with some of the ideas I had with regards to this language as well. Token streams, turn token stream to, so kind of, if I'm not simplifying it too much, kind of like a Lisp in a way, so where you have these macros and you can actually turn them, you can have, when they expand, they're turned into a token stream to be evaluated, potentially. In fact, in terms of the syntax there, where it's a string and it looks like the node name and node value are getting replaced, it does remind me a lot of potentially of a Lisp, but maybe there's a difference there. That, again, it's been a long time since I've looked at Lisp as well, or Lisp-like languages. But so let's see. If I have two objects and those are vectors of props, and similarly I'm going to, let's see, okay, yeah, well, like, again, there's crossovers, and I have heard it said that is that Lisp is iconographic or something. I'm probably butchering the word now, but the fact that it's data representation and its AST representation are the same, that gives it a lot of benefits, but I've always found that difficult to understand because I don't have any frame of reference. I have thought that it would be interesting to see what Lisp functionality in a more C-like syntax would look like. I'm sure there are examples that are out there that I could find if I just searched for it, but it is something that I've wondered in the past as well. So while I'm here, I'm wanting to, so I want to do a get sum. So if let sum y is equal to y's get, and so I want to enumerate over the, if I do just so it's a vector of, how are my objects being stored? Are they, I think they're vectors of props, and actually that could make things a little awkward for me here if that is the case. Let's see, hopefully it's a B tree. Object is an object type, which is a B tree. Okay, that helps immeasurably. Oh, okay, interesting. If you introduce Bash language keywords as a standard library, so it can actually, you can, in a way, you can define your domains, your DSL, in terms of keywords in the standard library, and then you can almost, in this new language, you can write it in the domain specific way that you need it to behave, potentially. Have I got that right? So here I'm going to Rust B tree. Does it have a length? Yeah, it does have a length. And so we're going to, if I do an iteration over it, I presume I'll get the keys. Yeah, each item is a tuple, I guess. Cool, polymorphic language. And so I want to get k there. And if I don't get k, then I'm going to return false. And I think this should do what I want it to do. In terms of a polymorphic language, I mean, I don't see why not. It's kind of like, in a way, any, or at least I would say the majority of the current mainstream languages, kind of C-style family of languages, essentially allow you to define your own DSL by, for example, just at the kind of type level and function level. So for example, I think, was it Java back in the day, or in fact, I don't know. I'm there are too many thoughts going through my head at this point, but you can kind of define your own DSL in terms of types, methods, and functions anyway, in a way that you can kind of define a way that you call and work with data. In fact, lots of frameworks are in a way a DSL, except that you're kind of constrained by the language that you're actually implementing it in. And it sounds like with the likes of macros, you're kind of getting an extra layer of flexibility. Groovy, yes, but even when I was saying Java, I was even thinking to back in the day when, at least it seems back in the day for me anyway, when I was playing around with the likes of, I think it was Google Guava. And I remember it was around that time that there was all this, I feel, hype around chaining calls, and you had these massive chains, and you could be very, I guess it was the influence of functional programming languages. And so it was the big thing that you could chain all these function calls and you could mutate the data in whatever way you want. But it's essentially what the Guava was doing there, in my opinion, was creating a DSL. So it was creating a set of types and a way of working with the data and manipulating data in kind of a pipeline fashion that could be considered a DSL. And the only thing that kind of distinguished that way of working from or the only thing that would maybe make that feel more like a DSL was just the syntax. But in terms of the way you were actually working with the data, it was kind of like a little DSL, same as actually Link for, I think, C#. And again, I'm not sure if Link even exists, or it probably exists in Codebase, but I'm not sure how prevalent it is in C# anymore. But Link was essentially a DSL for that kind of stuff, where it almost gave you, I could get butchered for this, but like an SQL like feel or experience in the middle of a C# program. So when you're dealing with a stream of data, you use this kind of little SQL feeling dialect to modify it, and then the data at the end looks and feels the way you expect. And similarly to how with Guava, it was kind of a library that gave you a DSL feeling. Link was a DSL where, for the most part, I often felt when I was working with it that you could achieve the same thing just using methods. And maybe there are ways in which it differs where using methods and the likes would be too prohibitive. But a lot of it, at least for my usages anyway, a lot of it did feel like, yes, it probably looked a bit nicer because of the DSL and probably had a little less noise. But I felt that quite often when I use a DSL, I can often feel like it can be difficult to know whether a DSL is really necessary or if the same could be achieved using just a standard library. And I guess with the likes of what you're describing in terms of a polymorphic language, or a language where you can kind of define keywords in the language to somewhat define your own DSL, I guess you're giving that power to the programmer to say whether they want to define their library purely in terms of methods and functions and the likes, or if they, so that it looks and it feels a bit more like a DSL, but has a familiar syntax, versus whether it has a almost bespoke syntax for the functionality that you're describing. So, I mean, it kind of comes down to in terms of practicality. I think the deciding factor. Well, there are lots of deciding factors. The big deciding factor, I guess, in terms of a language is how well it will get adopted. And I feel often the languages that get adopted can have lots of nice new features, whereas I think the languages that can be strongest, and this is where I feel something like I really like Rust, but I feel like it can suffer sometimes from the fact that there are, well, is it the case that there are lots of ways of doing the same thing? I don't know, but in general, I would say I can find Rust a little difficult to read, especially because there can be so much going on. And so, in terms of if you give a programmer that ability to define their own DSL so they can program in whatever way they want, I feel like that could be difficult to programming that could be difficult to maintain, because everyone can kind of write it in their own way, and it can make sense to the individual programmer, but overall someone new coming to a code base that's written with a bespoke syntax might be a little trickier to decipher than one that's written in a standardized way. And I actually, even in the way I write Rust, I have a lot of rules kind of constraining. I mean, it's mostly syntax and things like that, but I find that there can be, or even when I write Go, I have a lot of rules for even just restricting language features that I make use of, because there can be alternatives that make it a little simpler, because I know that's a whole other tangent, but to me, I get a lot of value out of simplicity of languages anyway. But it's also, it depends on what you want from your programming language as well. I mean, for me, at the end of the day, I'm writing this programming language for myself. And so once I have it done and once I get to play around with it, I'll have gotten what I want out of it. And if you have this idea for a programming language that you want to write, and you get to play around with those ideas and modify it the way you want, and like, it sounds like the value of that language is trying out that new idea. So in terms of feasibility, I would say it kind of depends on what you want out of it. And if what you want out of it is to learn and to have fun, then I suppose I said a lot of stuff before, but in short, I would say as long as you're getting what you want out of it, then I think that's the most important result. Yeah, I mean, like, the discussion of languages that get adopted is, I mean, yeah, I guess a lot can be said about that these days, in terms of the languages coming from big places. Any big organization is probably going to have a certain amount of marketing push that they can put behind it, that an individual isn't going to be able to combat, but an individual is going to struggle getting that same exposure that a large company has. And even beyond marketing, I guess there's just the clout. If you find out that a big organization with a lot of smart people in it has published this programming language, you're potentially going to listen more to them, versus if there's another individual that you don't really that you're not really familiar with them, you don't know what their credentials are. So you're like, okay, why would I because learning a language can take a lot of time, and for a lot of people who aren't actually that interested in languages themselves, but more what we can do with them, then it can be a big time investment. Having said that, I think if a language is focused enough and knows the idea that it wants to iterate on, and that has appeal for others, then it's like, I guess, any project really. I mean, if you have a new framework or what have you, and you're focusing on one idea that solves a problem that lots of people have, and the idea resonates with people, I think Zig is probably was it Zig? Could be an example of that, where I think that is an individual working on it primarily. And a lot of the ideas for me don't seem that novel or revolutionary, but they're, I guess, composed in such a way for performance and the likes that resonates with a lot of people that he was able to gather enough momentum. HTMX path shows that if you yeah, there is that. I mean, that's it partly comes down to marketing as well, I suppose, and there are a lot of ways of getting eyes on your project, but end of the day, it also, that's why I try to pair it back to that idea of is it too businessy to call it value, but it depends on how you measure the success of your project. And that's why for a while now I've basically tried to measure my success of my projects just based on my own satisfaction, because there are things you can do to influence other people to adopt your projects, whether that's buying them, paying for them, interacting with them, praising you for them, or whatnot. But for the most part, what other people do is out of our control. It's kind of a chaotic system, and we may be good at marketing, or we may have strategies that can help us get the results we want. But for me, I've released enough projects now where they haven't gotten the reception that I'd wanted or hoped for, to the point where when I start a project, for some of those projects, they would have been, oh, I'm developing this so that I can make a bit of money, or so that I can impress people, or things like that. And when that not inevitably, but when that happens, that I don't get that result, then it's like, oh, well, the project was a bit of a failure. So now when I start projects, I actually want to make sure that I'm going to enjoy them first and foremost. And if I have an idea that I want to see through, I want to learn something, or I want to get this bit of value out of it. I know I'm doing it for me at the end of the day, and if other people get benefit for it, same with this stream, for example. I mean, like, in terms of the viewership and subscribers and things like that, I think it's probably fairly low at the moment, but that's also not what I'm measuring the success of this stream in. More, I feel that writing a programming language is a bit interesting, and I felt like documenting that process, and even just having those videos set aside and having done that experience of streaming will be enough of an interesting thing for me that just in doing it will have made that experience worth it. Yeah. Well, you say Zig is an exception, but I think it can be applied to lots of projects. I mean, again, if you're talking about apps and things like that, lots of large organizations are going to be the ones that can bring out products that easily, I guess, scale to lots of users very quickly because they can do these marketing pushes. And same with game development studios. It can be big organizations that have the clout and resources to push, and then it's going to be exceptional that indies and individual developers and things are going to be the exceptions because they just don't have as many resources. And I think that's kind of, I guess, the fact that being an individual and doing these things, the fact that that is the exception, probably reinforces the point that ideally you'll want to be doing this stuff for yourself, because the chances of being able to compete against a big company or the likes is so tricky. But again, it depends on what you want out of things and how you define success. So it kind of, I know if that's a meditation thing or a Zen thing or what have you, I'm not quite sure, but definitely helps me, I guess, justify the use of my own time a bit more anyway. So equality on compound list. So I feel like I'm missing a test here. So I've got regular equality, list equality, and object equality. Maybe I should have a runtime error test. And how are we here? Equality. Yeah, I moved those. Yeah, and then if it's not equal, I invert it. That's all right. Yeah. And those are my tests. Did I add anything to, oops. There's a failure there. Can't apply equals to list and object. Oh, yeah, wrong position. Oh yeah. So that's at 1.4. And did I add? Yeah, I added some documentation on that as well. For equality operators. Did I say operations or operators? I said operators. So I will push that, and let's see what's next on the scratch list. So I think that's basically all the operations done, I will want to add support for return, but I think I'll wait until I have ifs and else ifs defined. In the meantime, do I have support for parentheses when it comes to expression evaluation? Yeah, and that could be a simple enough thing to add, because it shouldn't change anything with regards to the AST. It'll basically just, well, it'll change how the AST is constructed, but won't add any custom nodes or types or anything like that. So let's try this. And so I can add some new precedence rules, or rather tests. So what did I do there? So in the I'd say I can have that there instead. Okay, yeah, that's the EOF stuff again. So that's parse errors. And so I can add that there. And I'll get an error. Oh no, I didn't save that, so that's alright for the moment. By introducing parentheses, I should be able to modify all of these results. So that's then going to be 9, this is going to be 5, 2 divided by 2 will be 1. This will be 3, and this will be 5 modulo 3, 2. Well, I think that'll still be 2 actually. So let's try that. Yeah, it should be 2, but for a different reason. But I don't think that's clear with the test. So maybe I'll try changing that to 7. So that will be 7 modulo 2 will be 1 plus 1. 7 modulo that will be 1. Well, I had documentation on the parentheses and precedence. 26. In fact, let's change all of these. So 1 multiplied by... Oh yeah, that's also 6. So the issue wasn't the 3, but it was the 1. So we have 14 there, 20 there. 6 plus 4 is 10. And 2 multiplied by 7 is 14. Cool. So with that then, just a minute. Here we go. And do I want to do, yeah, operations, precedence. Whoops. So precedence. I have 595132, and that should be 1. So 7 modulo 3, yeah, that should be 1. Cool. And that is add support for parenthesized expressions. And so going back to the scratch pad, let's see where we are. Yeah, that's that done. Yeah, and I'll do operation assignment now next. That shouldn't take too long. And then I'll be on to control flow. So cool. That's did I only implement basic expressions? So I've implemented more or less, yeah. So I've implemented arithmetic, Boolean expressions, equality, comparisons, and string concatenation. Actually, what could be nice is list concatenation using pluses as well. Operator precedence, so it's the standard kind of, I guess, is it bird mass or so on. So where is the parser defined? So each layer of expressions is defined with a certain level of binding. So I think these are, the higher the precedence number, the looser the binding. So down here we have all these very tightly binding items. So creating a list or an object or a literal of some kind will be very tightly binding. And then as we go up the precedence order, a lot looser. So I don't have anything. I mean, the language itself, again, so this is going to be a kind of a core language. Maybe in future there could be another language branch off of it that adds in some crazy stuff like APL style array manipulation and things like that. But for this language anyway, I'll only be doing basic expressions, and well, it depends what you mean by basic expressions as well. Like I'll be also implementing, say, lambda functions or nameless functions, so that they can be functions are going to be first class citizens, so they can be passed around in variables and what have you. And let's see what else. Once I branch off of this language and do the more bash style, the bash alternative language, I'll be looking at doing more sophisticated built-in operations, such as spawning a process relatively easily from the program name and its parameters and capturing the output and so on. But for the language itself, Swift allows you to create your own prefix, infix, and postfix operators. Oh, I see what you mean now. And I think Haskell has kind of similar stuff as well. That's not something that's going to be in this language. And I mean, I'm very like a Luddite when it comes to those kind of defining your own operators things. I feel that most of the time when developers are given the power and flexibility to define their own operators is, I guess more often than not, it's abused for poor gain. I mean, some exceptions to that are the likes of NumPy and things like that, where you actually have libraries and frameworks that are dedicated for scientific and statistical operations that overload those operators in a way that makes sense. But other than those cases, I think the ability to I guess it kind of comes back to the DSL argument as well, and it depends on how much flexibility do you want the developer to have to write things in a way that feels neat and cool to them. Because the more outside the standard look and feel of the language that you go, I think in general less maintainable things are going to be, because operators and different syntax elements aren't doing the things that you might be expecting them to do. So it's kind of a for me anyway, I won't be adding that to this language. But they're cool tools and they're powerful tools. But I think I have very conservative views when it comes to programming language design and the likes of that. I often try to make my code a little too simple, and I like my languages to be maybe a bit too simple as well. But that's just my own opinion as well. But in terms of today's stream anyway, I'm going to start wrapping up there. Thanks very much for the discussion in the comments today. It was a lot of fun exploring different ideas. And yeah, so I think I was able to add most of the operators today that I wanted. So that's a nice chunk of work ticked off the tasks. And next, I think I'll be hoping to do is a few operator assignment operations, and then I will hopefully be getting to control flow. And once I've that done, I'll be rounding out the function implementation with some recursion tests. So yeah, like I wouldn't say that Go and C are necessarily my favorite styles of language, but for better or worse, they are kind of ubiquitous at this point. And regardless of your own opinions on those specific styles, the fact that they are so ubiquitous is a benefit in their own right as well. The fact that it is what a lot of people are familiar with, and if they're coming to your language, if someone is familiar with those styles and they're coming to your language, if your language shares a lot of those ideas, then it's like if you were developing a new spoken language using a Latin alphabet rather than kind of making up one of your own. There's just this, I guess, implicit knowledge that you get to carry with you and take advantage of when you reuse what's already there. But anyway, I'm about ready to pop off on another digression, so I'm going to leave it there. Again, thanks very much for all the chats and comments, and I'll see you on the next one. Take care.